Alright guys, here we go. We are going to look at rotations. I'm going to make this one hopefully a little bit shorter, but we're just going to look at rotations. And then at the end, I'll talk about some of the rules that you should have gotten from, say, reflections and this one with rotations. I mean, translations, the rules are right there. You either out of track, move left, right, up, or down. Okay, so anyways, what is a rotation? A rotation is a turn. For every season, turn. No, I'm not going to do that. That's just cruel. Anyways, a turn around a fixed point called a center of rotation. So obviously there has to be a center of rotation. So the figure rotates at a specific angle and direction. Now, to make this simple, we are just going to do 90 degrees counterclockwise about the origin. Obviously, you could do different points of center of rotations, and these would change the rules. But this is to, I guess, just kind of make the rules simple. So, what's the rules here? Okay, so if you have a point and you rotate 90 degrees counterclockwise, then notice what happens. The numbers would switch, and the y coordinate now has become the x, and it has changed its sign. Okay, if you do 180 degrees, notice that it just becomes the negative of both the x and the y. And then the 270 switches it, but this time the x is going to become the negative. Okay, so you kind of see how that works, and that kind of goes from there. Okay, so let's look at some examples, shall we? Now, guys, again, you don't necessarily need to, say, get graph paper to be able to do this. I mean, if you could do this in graph paper, that would be great. If not, I mean, I understand. So if you look at this, based on the rule, okay, so here are my coordinates, right? Based on the rule, this would tell you 90 degrees counterclockwise. If you look at the rule that you just had, or that you have in the paper right above you, you're going to switch these two around. So instead of 2, 7, it's 7, 2, change the sign of the first one. Or the y, whatever, the old y. Okay? 5, 6, change the sign. 1, 4, change the sign. That should be the rotation of 90 degrees. So let's look and let's see. Okay, so you can see here, the ABC, without the little marks, is the original. The red one is the original. And then A prime, B prime, C prime is the new one, the rotated 90 degrees. And you can kind of see, now, if you look at this, that's how I rotated, when I rotated that actually 90 degrees, and you see the numbers are pretty much on top. What's off is probably just how me messing up there. But you can kind of see how that kind of works, and yeah, that's all it is. Fairly simple, right? Yes, if you're wondering if this is fun, it is. It is just hilariously fun just to keep going doop, doop, boop, 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 back and forth. Anyways, so let's look at the next one, shall we? Okay, so again, notice here that this one is going to be rotated 180 degrees. So when you rotate 180 degrees, you're basically changing the signs of all these points. So now it's -2, -6, -6, -5, -5, -1, -1, -2. And that's really all it is. So how would that look? Let's see, shall we? And so you can see here, that one looks pretty much the same. Again, just flipped over 180 degrees. Keep in mind, what happened here, and let me see if I can do this, is you're not really reflecting this. You are rotating and then rotating again, so you can kind of see how that works. I didn't finish the rotation very well, but you get the idea. So you can kind of see how that works, and then you would see how like that was rotating around, again, this center point, the center of the origin. Okay? So last different example, I guess you say, is to 70 degrees, 270 degrees counterclockwise. Now again, remember, you're switching these points here, and then you decide, okay, change the sign, but you're changing the sign of this one that's going to now move over to here. So like on J, 4, 3, but then that one's going to become a negative. 4, 6, that one's going to become a negative. So the one that's moving into the y coordinate is the one that's changing the sign. I lost my train of thought. let's see here, 1, 8, negative. And then, well, 1, 1, that's kind of weird. Anyways, so you can kind of see how that works. Notice I'm not doing this with the cord or with the graph. I don't necessarily need to, but if you wanted to see the drawing, okay. So here you can kind of see the drawing, and again, if you wanted to see, keep in mind that you're rotating this so 90, 180 over to the 270. Okay, so you can kind of get the idea there and see how that works. So you can kind of see how those go. And again, those rules should not be too difficult. Hopefully you get those fairly easily. Okay, so not that you only did reflections based off the x-axis, y-axis, y equals x, or y equals negative x, but in general, when you do these simple ones, you could like realize something like this and use these kind of rules to help us figure out an answer. So, like if I had a reflection about the x-axis, I know that the x will stay the same, but the y will change, and then kind of go from there. How does this help me? Well, if I use these rules, that should get us to this next part. Okay, what if I wanted to do something like this, where I take, say, some points, and then I wanted to reflect them about the x-axis, and then do the rotation? Well, according to that, let's look at the rule again. It says if I'm going to reflect about the x-axis, I'm going to change the sign of the y. Then the rotation is going to tell me to, say, flip and change the thing. So let's look, see what would happen. To kind of give you an idea, what I did there was that I'm going to do the reflection and then do the rotation, and let me do it like this, and I'll show you this in two ways. So I'm going to put here d prime, e prime, and I know you've got this, f prime, and then here's double prime, double prime, double prime to recognize the second reflection. So this will be the prime, this will be the double prime. Okay, so that tells me that what I'm going to do here is say x comma negative y. So I'm just going to change all the y's, change the signs of all the y's. So you can see that's what I'm doing there, and going from there. Now, oops, I didn't change the sign of that one. Oopsie, let's try that again. Okay, now I'm going to take these answers and apply them to this rule, which says change the sign of the x and the y again. So now it becomes 6, negative 1, 3, negative 2, and 5, negative 7. And that should be my answer. So you can kind of see how this worked. You can see basically, and let me see if I can draw this out. So this, whoops. It won't let me flip. Okay, I was going to try to do a flip, but I couldn't. So you can kind of see what I did was I flipped the red one onto the light blue, and then I rotated the light blue over 180 degrees to where the purple would be, and you can kind of see how that works. Then kind of go from there. I want to do this one very short. Symmetry we will look at next, and dilation. Dilation is basically making them larger or smaller, and symmetry is just trying to make sure that you can cut them into lines that would be equal halves and things like that. So we'll talk about that later. We won't spend too much time on the symmetry, and maybe a little bit more time on the dilation. We shall see. Anyways, that is it for today. Thank you so much for your time, and if y'all again have questions or anything, feel free to just let me know. Y'all take care. Thank you.